Swayam Prabha. Digital India. Educated India.
Now we are going to discuss how to use the principle of fuzzy logic and neural networks just to design and develop adaptive gate planner. Now once again let me tell you that the principle of robotics which I am going to discuss here, you may not understand 100%. You need not worry. Once again the main emphasis of taking this example is to tell you like how to use the principle of fuzzy logic and neural networks to solve or tackle this type of problem. So, we are going to discuss how to design and develop adaptive gate planner. Now, this gate is actually the sequence of legs movement synchronized with its body movements during walking of a humanoid robot. Now, we human being while walking we follow some gait cycle. Now, let us see how to design one adaptive gait depending on the requirement. Now, during a walking actually a legged robot or a humanoid robot should be able to design and develop your adaptive gaits, otherwise it will not be able to negotiate so that particular terrain very efficiently. Now, here I am just going to take one example just to show you the walking cycle of a particular the biped robot. Now, this walking cycle consists of 2 double support phases and 2 single support phases. Now, here you can see a biped robot, the human robot is walking and in a particular cycle, supposing that so the left foot is on the ground and the right foot is also on the ground. So, this is nothing but the double support phase where both the feet are on the ground. Now, while walking, so what you do is, so this right foot that will be on the ground, but the left foot, so that will be taken away from the ground and this will be in the swing phase. Now, if it is in the swing phase and this right foot is on your ground, so this is nothing but is the single support phase. Then comes your so this particular the left foot we are going to put on the ground and the right foot is already on the ground. So, what will happen is this will constitute one double support phase and next what you do is, so this particular left foot will be here and the right foot will be taken from the ground and it will be in air. So, this is in swing phase. So, that is nothing but is the single support phase that completes actually one walking cycle. So, one walking cycle consists of 2 single support phases and your 2 double support phases. Now, while walking the biped robot or the humanoid robot should be able to maintain its balance during both the single support phase as well as the double support phase. Now, here actually the main requirement while walking like we should be able to walk by consuming the minimum power and at the same time the dynamic balance should be the maximum, we should not lose the balance. So, how to maintain this and let us see how to implement this with the help of fuzzy reasoning tool and the neural networks. Now, here let me spend on the physical problem. This is a very simple problem, very simple model. Now, here I am just going to explain. So, this is nothing but actually the single support phase, that means there is one foot on this particular the ground and another foot is on the air, and supposing that so this particular biped robot is negotiating so this type of staircase. So, this shows actually the staircase, and if you see the biped robot is a very simple biped robot having 7 degrees of freedom. And if you just want to show it here, so this particular foot is on the ground and so this particular foot is in air, and the swing foot, so it is going to follow this particular the trajectory while walking or while negotiating this particular the staircase. Now, similarly, if you see the limbs of this particular biped robot, so this is actually 1 foot. So, this is one link here, then we have got another link here, then this is the hip joint, then comes another link here, and here we have got the ankle joint. So, we have got ankle joint here, the knee joint here, and we have got this particular hip joint. In fact, all 3 points are coinciding. So, this is nothing but is the hip joint. So, this is the hip joint, and this is nothing but is your knee joint, and this is your ankle joint. So, this is the ankle joint, and each joint, for simplicity we have considered, it is having only 1 degree of freedom. So, 1 degree of freedom plus 1 plus 1 3, 3 plus 3 6, and here we have got another degree of freedom for this trunk. This is actually the trunk, and so it is having 7 degrees of freedom, say. Now, each of these particular links is having its mass and mass center. For example, if I consider, so this particular foot, it is having some mass and mass center. So, this particular link is having some mass and mass center, mass and mass center, mass and mass center. So, each of these particular link is having its mass and mass center, and supposing that I am considering the movement only in the sagittal plane. Now, if I consider movement in the sagittal plane, that means in this particular the biped robot is moving in this particular the direction. So, this is the direction of movement, I should say. Now, if this is the direction of movement, so what you can do is, so I will have to generate this particular gait, that is the sequence of the leg movement, so that it consumes minimum amount of energy and it can maintain that particular dynamic balance while negotiating. So, this particular the staircase. Now, if I want to model it using fuzzy logic and neural networks, so I will show you that a few things are important. For example, so here you can see, so at the starting, so I put the foot here, and that is taken as the swing foot later on. So, the initial position of the foot, that is from the edge of this particular staircase, that is nothing but x1, and the placement of this particular ground foot with respect to the edge of this particular staircase, that is nothing but is your x2. So, I can consider, so this particular x1 and x2 are nothing but the inputs for my gait planner. Now, if you see the way one old person walk or negotiate the staircase and the way one young person negotiate the staircase, there will be lot of difference in the sense, the place where they are going to put the foot will be different, like x1, x2 for the old person, x1, x2 for a young person will be different. And for the same person, if the slope is much for this particular staircase, so the same person is going to change this particular x1 and x2. And once we decide while negotiating the staircase the x1 and x2, then a few things are determined mathematically. For example, what will be this particular hip height? For example, if you see the old person, the hip height for the old person will be less, but for a young person the hip height could be more. Now, once you know this particular your x1, x2, and if I know these particular your the joint angles like theta 1, theta 2, theta 3 and also joint angles, so I can find out what should be your the hip height. And another thing is your the step length. Now, while walking, what should be my step length? For example, for an old person the step length could be less, for a young person the step length could be more. So, what we do is we try to find out what is the height of this particular knee joint and what is this particular your step length. And while negotiating the staircase, so we take the decision regarding x 1 and x 2 where to put my the feet. Now, all such things actually can be modeled using the principle of fuzzy logic that I am going to discuss. Now, in the previous slide we consider the single support phase, and this is actually the scenario for your the double support phase. For example, if you see in the double support phase, so I have got one foot here on the ground, another foot here on the ground. So, both the feet are on the ground. So, this is the double support phase, and this particular the link is having the mass m 1 and it is having the length L 1. Similarly, it is having m 2 L 2, m 3 L 3, m 4 L 4, m 5 L 5, m 6 L 6, and here we have got m 7 L 7. And for this particular the double support phase also, so we will have to find out what should be the adaptive gate so that it can negotiate. So, this particular the staircase by consuming the minimum energy and after maintaining the maximum the dynamic balance. Now, let us see how to implement or how to model this with the help of your the fuzzy logic and neural networks. Now, here you can see that I am using two multi-layered feed forward network. So, this is a 3-layer network and this is another 3-layer network. So, this is a 3-layer network and here I have got another 3-layer network. So, two multi-layered feed forward network I am using, and this x 1 and x 2 are fed as input to this particular the network, and here I have already discussed how does it work. So, I am not going to repeat that. So, ultimately I will be getting this H 1 and L 1 as the output of this particular the first network. Now, what is H 1 and L 1? H 1 and L 1 are going to tell you what should be the height of the hip and what should be your the step length sort of thing, that particular information, or what should be the projection of hip with respect to your the ground foot. So, that is nothing but is your L 1, and once you have got this particular H 1 and L 1, so mathematically we can find out what should be the joint angle. So, trigonometrically we can find out what should be the joint angle. So, all the joint angles we can calculate except that your the theta 4. Now, once you have got this particular the joint angle, I can find out what is the change in theta 2, what is the change in theta 3, and that will be fed as input to the second network. And in the second network as output we will be getting what should be the change in theta 1 and what is the change in theta 4. Now, let me once again go back to the picture. Now, here if you see, now what we are getting as output? We are getting as output is nothing but the change in theta 4 and your change in theta 1, that is nothing but the change in joint angle for the swing leg. Now, whenever the biped robot is negotiating the staircase, it balance largely depends on your the trunk mass, the angle of the trunk mass, that is your theta 4, and another is your the angle of this particular the swing foot, and those two things are the output. And once you have got those particular output, now we are in a position to find out what should be the stability, whether it is dynamically stable or not, and we can also mathematically found out what should be your the torque values, how much is the power consumption. So, I am not going for all such things because this course actually does not permit that. So, in robotics course actually we consider all such things and we calculate. Now, here, so the purpose of this is actually to find out what is the change in theta 1 and change in theta 4, so that the balance is maintained for this particular your the biped robot. So, this is the way actually we can implement the gate planning using the two multi-layered feed forward network, and the same problem can also be tackled using the fuzzy reasoning tool, and you can see that exactly in the same way. So, we can represent this particular x 1 as the input and x 2 is another input. We can use some linguistic terms like, if you remember, like low, medium, high and very high. So, for simplicity we have considered triangular membership function distribution for the two inputs x 1 and x 2, and I will be getting the output as h 1 and L 1, and that is nothing but the output of the first fuzzy reasoning tool. Now, using this h 1 and L 1, so mathematically we will be able to calculate what should be the joint angle values, and once you have got these particular joint angle values, exactly in the same way we are in a position to find out what should be the change in theta 2 and your change in theta 3, and this particular change in theta 2 and theta 3 it is going to follow some triangular membership function distribution, and as output you will be getting, that is nothing but change in theta 1 and change in theta 4, and these are the membership function distribution for this particular the theta 1 and theta 4. So, we can find out the joint angles so that it can maintain the dynamic balance, and we can also find out how much will be the power consumption. So, this is the way actually we can model so this biped working just to find out what should be the adaptive the gates. If you want to negotiate, so the different types of terrains or different types of the staircase in an optimal sense. So, this is how to use the principle of fuzzy logic and neural networks just to find out the adaptive gates. Now, if you solve it, in fact, we have solved it, and this shows the stick diagram during the single support page while ascending that particular the staircase, and this shows actually the stick diagram while ascending that staircase using during the double support phase. So, this is the way actually we can develop the adaptive gate. Now, I am just going to discuss another area which is very interesting, and we can use the principle of the fuzzy logic and neural networks also just to develop the intelligent data miner. So, the problem which I am going to discuss is nothing but is your intelligent data mining. Now, this particular problem of intelligent data mining, the purpose is how to model the input output relationship of a process in both forward and reverse direction, and if required, whether we can map the data from higher dimension to lower dimension for the purpose of visualization, whether we can do some sort of clustering using the principle of similarity. Now, here the input output data are clustered based on similarity. We do some mapping from higher dimension to lower dimension for the purpose of visualization. Now, this I have already mentioned that we human being can visualize only up to 3 dimension. Supposing that the data are in say higher dimension. So, for the purpose of visualization, so we will have to do the mapping. In fact, we can use self organizing map for carrying out so this particular the mapping, and we can also carry out some sort of clustering also using self organizing map or some fuzzy clustering tools like fuzzy C-means clustering or entropy based fuzzy clustering and so on. And once you have got this particular cluster, now let us see like how to develop the reasoning tool. It is very interesting. Now, supposing that say I have got the higher dimensional data. So, this represents the higher dimensional data. So, this is nothing but the higher dimensional data, and I have got a large number of data points here. So, we have got a large number of data points like input output relationship, and our aim is to design and develop one expert system, so that you can do this particular the input output modeling as accurately as possible. Now, what we do is we first try to carry out some sort of your clustering based on the similarity, and based on the similarity. So, we have already discussed some tools like fuzzy-Siemens clustering or entropy based clustering. Supposing that we have got some clusters here. So, I have got one clusters here and it has got a center. I have got another cluster here, say it has got a center. I have got another cluster here, so it has got a center here. I have got another cluster here, so it has got a center here, and so on. For simplicity, let me consider for the timing there are only 4 clusters. The data are such that we have got only 4 clusters. Okay. Now, if this is the situation, and supposing that this particular data are in higher dimension, so we cannot visualize that particular the cluster. So, what we will have to do is we will have to use some your dimensionality reduction technique like self organizing map, just to map this higher dimensional data to the lower dimension. And if you can do the mapping, so very easily you can see, very distinctly you can see, so these particular the cluster. Now, once you have got this particular cluster, now what you can do is we can go for some sort of cluster wise regression, or we can go for some sort of fuzzy reasoning tool, development of fuzzy reasoning tool, so that you can do this mapping, or we can do this particular modeling very accurately. Now, let us see how to do it. Now, supposing that we have got say 4 clusters, for each of the 4 clusters. So, I have got a cluster center, and the cluster center has got some property. So, what I can do is I can carry out some, I can use some fuzzy reasoning tool here, so just to find out the input output relationship, or I can use some neural network here to find out the input output relationship. Similarly, I can find out another fuzzy reasoning tool or neural network, another fuzzy reasoning tool or neural network, another fuzzy logic tool or neural network I can develop. Now, supposing that one new test case has come. Now, the moment you find a new test case, supposing that the test case is here. So, this is I am supplying the set of inputs, and our aim is to find out what should be the set of outputs. The moment I pass this particular test scenario, so I have got the set of input parameters. So, these set of input parameters will be compared with the set of inputs of C1, the first cluster center, then it will be compared with the second cluster center, then the third cluster center and the fourth cluster center, and we try to find out the Euclidean distance values between the test scenario. So, this is the unknown whose outputs are not known. So, this is the test scenario. So, we try to find out like what should be your the cluster center, the distance between this point and C1, the distance between this point and this center, and this is your D3 and this is your D4, and you try to find out the similarity between. So, this particular test scenario and each of these particular the cluster center. Now, the more the Euclidean distance value, the less will be the similarity and vice versa. Now, and the more will be the similarity, the contribution of that particular cluster towards the output of this particular the test scenario will be more. Now, supposing that, so this particular data point is found to be very close to say C2. So, while determining its output for this particular the test scenario, so this particular your C2 will have more contribution while determining the output of this particular the test scenario. This is the way actually we can implement the data miner. And here actually what you can do is we can make it intelligent also. Intelligent in the sense like the quality of the cluster, each of the cluster depends on a number of parameters. For example, if it is fuzzy-Siemens clustering, it depends on the number of clusters which we are going to make, then comes the level of cluster fuzziness. If it is entropy based clustering, if you remember, it depends on the parameters like alpha, beta and gamma, and the quality of clusters will depend on. So, these particular parameters like your alpha, beta and gamma. Now, what you can do is you can link it to one nature inspired optimization tool, say genetic algorithm, and so this particular genetic algorithm will try to evolve all such optimal parameters like alpha, beta and gamma depending on the nature of this particular the data set, or if it is fuzzy-Siemens algorithm. So, it will try to find out what should be the number of cluster center and what should be your the level of cluster fuzziness, say denoted by G. So, those optimal values show that. So, this particular your reasoning tool, the fuzzy reasoning tool will be able to predict the output as accurately as possible, and GA through a large number of iterations will try to find out what should be the optimal parameters of this particular clustering algorithm, so that it can make the clusters in an optimal sense, and using these optimal clusters. So, we will be able to predict the output for a set of inputs very accurately. That is actually the concept of intelligent data mining. Now, for this intelligent data mining actually your makes a very good sense, practical sense. The reason is your supposing that, let me take a very simple example. Say I have got say one 3-dimensional data. Now, for this 3-dimensional data, if you want to represent, we can do it very easily. I can just consider the corner of a room like x, y and z. So, the whole volume of a particular room will be the search space or the design space for this particular the problem. Now, generally the real world problems are nonlinear. Now, for this nonlinear problem, the level of nonlinearity may not be exactly the same at the different regions of these particular the variables. Might be at some corner the degree of nonlinearity could be more compared to some other corners. So, that is why this particular concept of clustering makes a very good sense. If we want to determine the input output relationship, so it is better to go for this type of clustering, and clustering based regression, like it could be your fuzzy reasoning based regression, or you can use some neural networks also to determine, and after that actually we can combine. So, this is the way in fact we can develop the intelligent data mining tools just to determine the input output relationship in a very efficient way. So, this particular your the fuzzy logic and your the neural networks has got a large number of applications. Now, here quickly I am just going to take one example which we have solved. It is actually the screening and prediction of psychosis. This work we carried out a few years ago. Now, we carried out some sort of intelligent data mining using some data related to psychosis. Now, for this psychosis, in fact, we consulted some doctors and we collected the data, and there are 24 symptoms related to this mental disease or psychosis, and the data were collected with the help of 40 doctors, and we carried out some sort of screening using the clustering, and we carried out some prediction using the fuzzy reasoning tool. Now, let us see how to carry out. So, this particular your screening and prediction for this psychosis using the fuzzy reasoning tool. Now, as I told that we consider 24 parameters. So, here you can see that we are considering like your 1, 2, 3, 4, 5, 6, 6 plus 6 12, and the next slide you will find 12 more. So, we have got 24 the parameters, or so we consider in that particular the model, and using that 24 parameters actually we will have to classify, or we will have to do the clustering into 7 grades of mental disease or the psychosis. Now, the 7 grades of mental diseases are as follows. Now, these are schizophrenia, then comes your mania, then depression with psychosis, then delusional disorder, schizoaffective disorder, organic psychosis and catatonia. So, there are 7 grades of mental diseases or psychosis, and we collected a huge amount of data with the help of 40 doctors, and those data were actually the clusters using the fuzzy C-means clustering and entropy based clustering. Now, here you can see very distinctly, I can show you there are 7 clusters of these particular the diseases. You can see that. So, these 24 data, that means it was in 25 dimension. So, those data were clustered, and then the mapping was done to 2 dimension for the purpose of visualization using the self organizing map, whose principle I have already discussed. So, after doing this clustering using fuzzy C-means algorithm, and after carrying out the self organizing map based analysis, so we could find out the 7 distinct clusters of these particular the psychosis. And it is very interesting that we can find out, for example, this is one cluster, this is the second cluster. Similarly, you will be getting actually the 7 clusters of the psychosis. Now, this is the for the same data using the entropy based clustering. So, we got the 7 clusters, and here once again you can identify the 7 different clusters very clearly. And once you have got these particular clusters, as I discussed, like we could develop some fuzzy reasoning based the predictive tools, and using that fuzzy reasoning based predictive tools, we were able to predict the status of a disease, like the degree from which a particular patient is suffering from the mental disease, that could be predicted using the fuzzy logic based screening and prediction system. So, this is the way actually we developed that intelligent data miner for carrying out some sort of screening and prediction of the mental disease. Now, this particular thing has got a very practical meaning in the sense, supposing that one expert of mental disease, so one medical doctor, say he is examining a large number of patients one after another. The moment a particular patient comes in front of him, he generally asks a number of questions, and he tries to find out the similarity of the answers he is getting with those 7 well defined the clusters, and he tries to make a fit, like whether this particular patient is going to fit to any of the clusters, or he is totally unfit, he is not going to fit. If he is not going to fit, he is a mentally healthy person, and if he is going to fit to a particular clusters, so accordingly the medicines will be prescribed. So, this is the way actually the medical diagnosis can be carried out for mental disease using your fuzzy reasoning tool, using fuzzy clustering, and the data can be mapped for the purpose of visualization. Thank you.